some tools and architectures that we've seen proven out to be good solutions, and some other platforms that you can use to help you achieve these solutions. So just a little bit of background on who we are. We're a system integrators company. We have about 180 employees now, and we're spread across 8 offices. Eric and myself work out of our DMC office, and we're a National Instruments Alliance partner. We have over a dozen CLA and CLD certified engineers, so we play a lot with LabVIEW. Like everyone here, we all love it. We think it's a really cool tool to use, and we're excited to present for you.
So first up is to talk about what platform-based test architecture actually means. And kind of the goal of what we want to talk about today is you don't need to reinvent the wheel. So to kind of step back and have a little analogy is who uses an email here? Probably all of us. Who writes their own email client so that they can, do everything themselves? No one, right? I use Gmail on my phone and I use Outlook on my computer. That's because this problem has already been solved, so we don't need to do that again. And the same is true about the space that we work, right? The test and measurement space. If you need to sample some kind of signal, you don't build the hardware yourself and write the entire driver in like assembly. You use NI hardware, you use like DACMX, and you write a program in LabVIEW because this has already been solved, so we get to use this tool. So these pre-built platforms kind of save you guys time, so you can focus more on actually solving the problem with LabVIEW rather than kind of developing the extra stuff that has already been solved. So some of the pitfalls that a lot of our clients kind of work with, right? We've worked with a ton of clients, and we've done a ton of these projects, and a lot of the time they don't really want to explore other options because they think that the tools that they currently have are the best ones available, right? Or they think they're good enough for now, and they'll look into more complex tools later on. In summary, the 2 reasons that people fall into these pitfalls are, 1, they don't know about these other options, and they're not armed with the information to actually choose them. And 2, they don't want to actually invest in these solutions that are more likely built to last. So the solution to this problem is simple, and our #1 takeaway from this whole presentation is to, 1, understand your options, and 2, actually invest in them. It's important to know what tools are already available and to know what platform is right for your project. And if your project doesn't last more than a couple of days, and it's never going to change, then you guys can leave. You don't need to listen to this presentation. But for the rest of us, our requirements are going to change. We're going to have to actually continue to develop our application even after we get the first set of requirements. That's for us. And platforms are key, and it's going to pay off to put some thought and investments into the tools that we actually use.
So let's start by talking about how software architecture can fit into building these scalable solutions for the future. So let's start with the situation that I'm sure we've all been in here. We have this piece of hardware on our desk, and we have to communicate with it. So that's not so bad, right? We write some drivers for it, we write some code to take measurements with it. Maybe we spend a bit of time getting that communication to actually work, but we can all do it, it's not so bad. And then we learn, oh, well, the client actually wants to run some ad hoc tests on this now, so now we should build this whole ad hoc testing interface. You have to add in some stimulus control, maybe a PID, maybe you spend a bit getting that PID actually tuned. You have to put in some logging, that takes a little bit, some reporting. You have to do this kind of operator interface so that they can configure everything that's going into these tests. And you always spend a bit of back and forth. I think as Stephen mentioned, getting the operator to agree on this interface, that they like it, it's easy to use. But that's something we've all done. Nice job. Let's wrap it up. Everyone's happy with this. Except now they want to go from manual testing to running some automated tests. So now we have to think about this. How can we make this work? So we look at our ad hoc testing. We kind of take all the reusable components that we've had in that, and we build these into some blocks that we can kind of run in a sequence. We make them so that they can be reordered into any test sequence that the user wants to do. But now we have to add in this test sequence configuration, and we have to do a whole new interface for this so that the operator can make these ahead of time. And we have to keep this old ad hoc testing functionality as well for when they want to do that. So now we kind of need to restructure our application to do one or the other and still make everything look nice. But take a breath, you finish that, it's great, the client loves it. In fact, they love it so much that they now want to put it on multiple systems, and they're maybe not in the same building, they're maybe not even in the same state. So now you are managing multiple systems all at once. Yay. And you know, they would love to keep working with you. They want you to keep deploying updates to all these systems. They would want to be pulling data from all of them. Maybe they want to add in some user management so that they can manage who's actually seeing this data and interacting with it. And maybe now they want to add some reporting, you know, to kind of aggregate data from all these and get some actual useful information out of it. So at this point, you as the developer are struggling to keep up with all these changing demands, and I'm sure that your original application to talk to this device is really struggling to adapt to all these changing requirements. So does this situation feel a little familiar to anyone here? Have we experienced this? So I think that this kind of illustrates the importance of taking some time initially to set up a good architecture that you know will be able to adapt to all this inevitable change that's going to get thrown your way.
So what actually makes a good architecture, right? It's one thing to say, yeah, it's a good architecture, it's going to sustain, but what actually makes it good? Well, number one, it has to work. It has to actually satisfy some set of requirements and do what it's supposed to do. That's the easy stuff. It has to be scalable, and by that I mean that it's flexible enough that it can adapt to future requirements that will occur. It has to be able to be debugged easily, because you're not perfect and you're probably going to write some bugs in your code. And other developers are going to have to find those bugs, and if your program is hard to follow, it's going to take longer to debug. It needs to be able to support a team of developers, so that means work can be parallelized and you guys can focus more on developing the actual application and not worrying about conflicts between your two VIs. And once it's done with your team, it's going to go be handed off to someone else, and they have to be able to follow your code too. So it needs to be able to survive future developers. If you're done with your code and you leave it for someone else to manage, and it's not easy to follow, then they're probably going to scrap your work entirely. It has to be well documented, and good documentation doesn't just mean that it's long and thorough, it also means that it's approachable and accessible without being overly burdensome. So now we can go back to this map that Sammy originally put out, and we can leave it blank. And this is going to be, we're going to take this time to walk through each of these boxes and talk about what tools already exist that we can fill in all of these blanks. And I'm sure the first thoughts coming to all your minds is that we could just use LabVIEW in all of them, right? And you can do that. LabVIEW is a super flexible tool that can solve a lot of the problems, but we're not really here to talk about what LabVIEW is good or not good at, but rather what are some alternatives that either NI or other options exist so that you can still focus on your LabVIEW toolset without worrying about other aspects of your code that may be better satisfied by something else. So first we're going to start with the lowest level at hardware drivers.
So in this spirit of good architecture and reusability, let's talk a little bit about driver abstraction. So a big thing about driver abstraction is it means you're not tied to one language, you know, because software languages don't live in isolation. As we can see from this map here, there's many ways that they can all interact and work with each other. And this means that you can write different parts of your application in different languages based on, you know, specific requirements, maybe developer abilities across your team, or reusable code. So say, you know, we're talking about don't solve problems that are already solved. If you find, for example, this driver that someone's already written for this piece of hardware you're trying to interact with, but it's not written in LabVIEW, you don't have to rewrite it in LabVIEW. You don't have to waste time doing that. You can work more on the other problem. But if it's written in Python, if it's written in C, it will still be able to interface with your data acquisition application. And conversely, you can use other languages to speak to NI drivers. So take, for example, DACMX. I'm sure we all love DACMX. It's an awesome hardware driver that allows your LabVIEW code to easily interface with NI hardware. But if for whatever reason you can't use LabVIEW in your application, maybe your company prefers all of your testing software to be built on a .NET stack, I don't know. But that means you can still use your NI hardware because of the compatibility of DACMX with all these other languages. So if you find your problem's already solved, just not in LabVIEW, that's okay. And I think that this is a good time to take a quick aside into an architecture note about object-oriented programming in LabVIEW. So in the spirit of reuse and abstraction, it's extremely useful to use an object-oriented paradigm in your approach, and at DMC, we really highly encourage it. So this is a very familiar design pattern that many other developers will recognize, so this helps with scaling it up. Future developers can come in, they already know what you're doing, they're on board, it's very flexible, and your software will be capable of tolerating, changes in both features and in your development team. So going back to this big picture that we've kind of made in our heads, a really classic place for object-oriented programming to come in is in the hardware and measurement abstraction layer. So just another example, let's say you have this power supply that your application uses. You've written your whole application to communicate with this power supply, but at the last minute your client comes in, they have this different model that they would like to use. You have to rewrite your whole application to now communicate with two power supplies. Maybe you have to rewrite it so that they choose at the start which one they want to use. Well, if you had started with an object-oriented approach, you could have this parent class that's just generic power supply, and a child class that overwrites with specific communications to one single one. Now when your client brings in this different power supply, you just need to make a different child class, and your actual application would remain unchanged in that example. So I could spend an entire session about how to use these object-oriented approaches, but luckily for you guys, it looks like a lot of other people today have done just that. So I would encourage you to attend those to learn more. But defining and separating your devices using object-oriented programming is highly recommended. And I think it can be a building block for teams of developers, which I think we all know that classically LabVIEW isn't very multi-developer friendly. So if you're using multiple classes, each developer can work on a single class without really conflicting with each other in that process.
So now we can go up one level, right? We started at the hardware level, and now we can go up to where I'm sure most of us are really familiar and comfortable. And that's where LabVIEW lives. This is the actual test and measurement application side of things. So looking on the left side where we have ad hoc testing, right, this is more of your manual stuff. This is when you just want to be able to sample some data, maybe do some basic logging, maybe some pretty basic stimulus control. Maybe you don't need to spend a bunch of time writing a LabVIEW application. Maybe you want to, but your client doesn't have too much of a budget and they just want something super, super simple. Well, that's something where FlexLogger can come in. That's actually an application that was showcased at NI Week last year, and it's just really great for basic I/O and some really basic logging tools. But if you need to go above that, that's where LabVIEW shines, right? So this is, I'm not going to spend too much time talking about LabVIEW because you guys know it and you guys know exactly what it's good for. But it really shines in this space. And if we go to the right side of this map, we still have that area that is kind of that ad hoc testing, but it's no longer manual control, but it's still able to interface with higher level automated testing. But before we go too further, if you guys can't stick with the NI platform, this is still where interoperability can take place. So if you guys are in charge of writing LabVIEW drivers, but a different part of your team is in charge of writing this part, even though you wanted to do it in LabVIEW, someone else is in charge of doing it, they can still write in a different language. You guys can still focus on LabVIEW either lower down in this list or higher up. So let's take a step higher on the right side and go to the automated testing side of things. So this is where Sammy was drawing the map before, this is where you guys have test configurations and you guys are doing automated testing sequences where a client can just select what test they want to do, they can configure their tests, and then they actually just run automatically for a couple of days or a couple of hours or whatever. You don't actually have to have an operator controlling or sampling everything. It's all done automatically. And this is where NI testing comes into play, if you guys are familiar. So back to the beginning of the presentation when I was talking about that email analogy, the same is true for the test and measurement space. So even though you could write your own test sequencer, you don't have to, and LabVIEW has already done that with TestAnd. So TestAnd is a pretty basic sequencing application that allows you guys as the developer to focus more on developing functionality and developing sequences rather than creating an entire sequencer and sequencing developing environment. So you can, just some of the out-of-the-box features that TestAnd actually offers, you can develop code in other programming languages, think like hardware drivers or accessories, and you can have them called by a test stand sequence. It also has some pretty basic report generation and database integration as well. So the test stand engine can collect data like statuses, errors, pass-fail information, and log them to pretty standard text-based formats. Additionally, if your client wants to have a SQL database on the side that's logging this information, that's built in as well. You can also opt to run tests directly from the test stand interface, but you can also use LabVIEW to create better, more intuitive interfaces. Maybe you guys could take some of the tips that Steven shared from his UI presentation earlier today. So teststand is a pretty basic sequencer that's useful if you guys have many projects with similar simple testing logic. And you guys need to create the same things over and over again. But I know that there's probably some pretty strong opinions about the software. So that's okay. Our goal here isn't really to tell you what's best for your application, but rather just explain that teststand is something that exists. So again, teststand is good for running basic automatic tests that don't need to be super dynamic during runtime. However, you're going to want to look for alternatives if your tests are running on a deterministic real-time system, for example. So many organizations will need to have different types of flexible solutions. For example, at DMC, we have our own internal sequence engine that's actually written in LabVIEW, and that's used internally throughout our entire organization. And I know kind of the point of this presentation was saying that you should use tools that already exist, and now we're giving you an example of how we use LabVIEW to do something, but the idea here is that we as a company have standardized on that, so if we aren't really reinventing that wheel has already been created. So we can continue using that, and we have resources internally that we can ask for help if we need to actually develop something custom. So yeah, if you guys want to learn more about teststand, I think that there's another presentation later today to learn a little more about that. But also, talking about interoperability, you guys can still create your LabVIEW measurement applications, but if you do need to have something higher up in this automated testing space, you can still work with someone else in your organization to create like an application in Python, for example, and you guys can still focus on the LabVIEW side of things.
So going back to this, the higher layer on our overview that we've been having this whole time, we're going to go back and talk about what if you have to manage many of these systems all at once. So we're going to talk about NI System Link, which is a good way to do this. So anyone who's really spent time programming test and measurement applications knows that it gets pretty challenging pretty quickly to manage multiple systems. You know, I mentioned sometimes they're not even all in the same state. And so you're building a custom application. That's the part that we all like to do. We're all really good at that part. But now maybe you need to deploy to multiple targets all at once if you found a bug. And maybe that means you're walking around for half a day with a flash drive going to each one of these targets out in the field. And that's time that would be much better spent on the actual debugging process than the actual rollout itself. And you have to keep track of which version of your application is on all these machines. Maybe you have to keep track of what third-party software is on them and what versions of those. Maybe you'd like to have some diagnostics for the health of your test equipment. You know, if you have this enclosure fan that gets clogged and stops really working, how will you really know about it before it's too late and your PXI controller overheats and reboots and kind of drops off? So you take the time to kind of program this in your application, but that's not really your area of expertise anymore. If you're logging data from these, do you have to go by one and kind of pull files off each machine to get the data you're interested in? So these tasks, if you're doing them yourself, they start taking a lot of time, they add up, and this isn't really the fun part anymore, is it? So that's valuable time that could be spent in your domain of expertise, actually working on the core code. So historically, this has been like a bit of a gap between test engineers and the organizations that are managing these, and there hasn't been a lot of tools for these higher level needs. So there is one now in System Link, which makes managing distributed systems like these pretty easily. It enables you as the engineer to connect, to manage, to deploy software to this whole fleet of devices that's out in your field. And it's not really targeted at a specific industry, so it's pretty widely applicable to a lot of applications. It will show you the version of each device that's currently running, as well it has some health diagnostics to measure its performance. It's all done through a web browser, so you can do it from any location, and it allows you to set up dashboards for data visualization, stuff like that. And I think that it was pretty heavily featured at NI Week last year. I'm pretty sure they'll continue to do that this year. DMC is actually doing a presentation on it if anyone will be there. We actually have used these, so we have these tilt table demos. They go to career fairs. They like to catch people's attention. It's an iPad with 3 actuators on it that keeps this ping pong ball centered on the table. But since they're at all these career fairs, they are spread all across the country. So we use SystemLink to manage them and deploy updates. So just so you can kind of see what it's like here, you can upload packages to these feeds. So a package would contain, the executable, any supporting software that it needs, and your devices can kind of subscribe to these feeds to get updates in that way. It'll list, all the software that you have currently deployed on a device, as well as the version that it's on, and it gives you the ability to change that if you've uploaded it to the feed. And you can also read from these tags. In this example, we're doing locations, so we can kind of see where they all are. And so it's pretty general, and I think it does answer, the need for a way to manage these huge distributed systems so that you don't really have to write something and do it yourself.
So the purpose of this presentation was to talk about how you can leverage existing softwares and platforms rather than reinventing the wheel entirely by yourself. So you can use, by using verified and extensible platforms, you can focus more on what you guys like to do, writing LabVIEW code. So this results in more flexible and long-term solutions for your applications. That concludes our presentation today, and it was a little shorter than the other one, so I'm definitely hoping we can have some conversation about what tools you guys have created in the past. If you've addressed or run into these issues before, and maybe you're interested in some other products that NI or others already offer, and if no one's interested at all, then we can break early for lunch.
I had a question about the system link. So 2 questions. One is, what is the deployment architecture look like for implementing that? And then what's the licensing structure for that?
Great. So I think Stephen can answer the first question a little bit more. He's our expert.
So I've used this a bit before. It is, I guess, first off, SystemLink is a relatively new product. So a lot of features are still coming online, so just be aware of that. That being said, one of the features that they have focused a lot of energy initially on is the application deployment, which I think that was your first question, right? Is the question, how do you deploy?
Well, SystemLink, how is it structured? And so if I have existing ATEs and software, and I've got them deployed throughout the plant, is there a way that I can use that for existing systems, or is this something I can only use for new stuff that I start rolling out?
No, you could definitely add it on. If you've got 10 test stands out in your facility, whether they're C-Reel based or PC based, there's a SystemLink client that you would install on those devices, and then there's a SystemLink server application that you can, I think the option is either you can pay for an I to be hosting that for you, or you can host that on your IT's internal server, setting that up, and then from there you can add devices. So your SystemLink server has like managed devices that it's in charge of, and part of the subscription model for this the SystemLink product is that you pay for, I think out of the box you get 5 nodes. After that it's like $160 for every additional node, but then from there what you can do is you've got your SystemLink server, and if they're C-Rios or I guess even PC applications, you can say, yep, all 10 of these are going to get version 2.0 of the software push, and it'll update. There's some more advanced features than that, but that's generally how the update process for that works. It's kind of a push.
All right, thanks.
Yeah, was there a second part to the question?
Well, you covered both of them.
Okay, so the SystemLink, it was licensing, right?
Well, yeah, you mentioned about the licensing. So you
So-
get 5 nodes to start with, and then it's 160.
Well, they usually bucket it, so they usually do like 5, 10, 25,
Right.
50, and you pay for the server node, or you pay for the server license, and then you pay for like a bucket of node licenses.
Okay.
Yeah, I believe the server license is around $1,800 if you're using a subscription model, which I would recommend at this point since they are bringing on new features. You want to get those updates, so you want to pay for a perpetual license at this point at least.
The other thing is SystemLink does not work with very old versions of LabVIEW or TestStand or other NI software.
Very old being described as pre-7.
I think it's got to be like 2014 area or newer.
It also doesn't work with FarLab, so it's Linux and Windows only.
Any other comments or tools that you guys have strong opinions on, one way or the other?
So,
Yep.
so you guys decided to build your own sequencing application. What was the reasoning behind doing that? What did TestN not provide that you wanted to have?
Yeah, well, I believe we actually started developing it way before I started at DMC. And I think it was around the same time that TestStand came out, if not even before. So I think it was addressing a space that doesn't even exist. If you have anything to add to that? But
Yeah, I mean, the other thing, I think the problem that a lot of people have run into with TestStand is just that you don't get that RT support. So we've tried to run sequences on a real-time controller, and you just can't do that. TestStand's only PCs.
Yep.
So having a sequencer that can run on PC or real-time is huge value to us. We don't have to teach people TestStand and our own custom sequencer depending on what application it is, so we just do the one for all applications.
So do you run deterministic sequences then on real-time systems, like really tight timing, or is it just running sequences on an RT system?
No, we do run a sequence engine with the tight timing on the C-Real or PXI platform.
Have you built that to do distributed I/O, like multi-target systems?
Multi-target systems. I'm trying to figure out. Can you tell me a little bit more about
Like
that?
2 C-Reos or a PXI and a C-Reo, or
So you have a host PC that's talking to a bunch of different controllers, which themselves have sequences running on them, or something like that.
any which way. I'm more interested in how if you run sequences on real-time sequences on distributed systems where you've got multiple controllers with outputs that have to be part of that sequence.
I know we have done a project where you had a main PC that was connected to a PXI chassis that had like a Mixie bus, and that was connected to a couple of Ethernet expansion chassis or something like that. So you had I/O coming through on a lot of distributed C-Reos or expansion chassis, and there was a central PXI chassis that had one or more sequences running in parallel on that were managing the I/O. That was a more complex application. I don't know that we've necessarily had sequences running on individual real-time targets though, but I don't see why you couldn't set up something like that. I don't have any experience with it though.
I know one of the things that caused the last company I worked for to build our own sequence engine is TestStand is unwieldy. It's completely unwieldy. If you want to set a variable, it's 3 menus down, and just writing simple test sequences took far too long, and editing them took longer than it should have. So we went to an Excel-based sequence engine, and just had all of the functionality we needed and none of the functionality we didn't. So that's one of the reasons to not take an off-the-shelf engine.
You're saying it's like so full-featured that it can be like very, very complex.
Yeah.
You've got like a simpler.
Yeah.
The basics are complex, right?
Yeah.
I mean,
Oh,
that's how I feel about testing.
Uh-huh.
Is like, the basics,
And you can-
that I want in a sequencer or an executive are complex to get
Uh-huh.
to.
You can do anything with it, but that means you can do anything with it.
Yeah.
Which is sometimes needed. I mean,
Yeah.
like, especially when you're talking DVE tools as opposed to ATE tools, DVE tools, at Microsoft we had this system that kind of evolved over this period of years that ended up becoming, it was basically just a GUI, and you could write scripts, and I provided a JSON web service that ran in the background, And people could write scripts in C, people could write scripts in Python, people could write scripts in PowerShell, I don't care. And I just provided an open API for it, and because you had so many different teams working on so many different products, that ended up being the way to go. Because if I would have tried to provide a test sequencer that worked for everybody, we would have needed a team of 12 people, whereas it was just me. And I could provide, you know, high-speed data acquisition tools and interface, and instrument interface for scopes and power supplies and whatever, and have a basic framework, and it was all OOP. So a lot of the times it didn't even matter like if they knew what kind of equipment they were hooked up to. You call an oscilloscope and it works, you know. And that can also be a solution. That's a more niche solution. Probably not a lot of organizations would need something like that. But yeah.
Can you go back to the last block diagram that you showed? And then will these slides be available in PDF or something online?
Is there somewhere for this event where we're putting up all our presentations? Does anyone know? We can also put it on the DMC website.
I'm sure Jared
Yeah.
would coordinate that.
Yeah,
Yeah.
we'll put it up where.
And I just want to compliment you on, this was a really, really well done presentation.
Thank you.
Really great.
Found out about the morph tool and I went wild.
Very professional.
Yes?
What other platforms or tools has DMC decided we're going to invest in our own architecture, and why?
I think that Veristand is something that we've kind of invested in our own sequencer a bit, just because it's also a little unwieldy to use. I'm trying to think of some other examples.
So just to clarify that,
Yeah.
we've steered away from Veristand. So we use the sequencer in applications where you might consider using Veristand. The sequencer, as you mentioned, is one of the big investment areas. We have a state machine. I don't know if anybody's familiar with top-level baseline prime. I think, I forget the guy's name, he's presented at NIWeek a few times on it. We don't have the same thing, we have something similar, but it's kind of a good state machine architecture for applications that are good state-based things. And then the other area of investment that's been more recent for us is in a alternative to the actor framework. I know that's very popular. We've had, I would say, conflicting opinions on the actor framework. And so we try to come up with a different, a by reference object-oriented class model to leverage and kind of try to move LabVIEW object-oriented closer to what you'd see in object-oriented programming and other programming languages. So those, I think, are the three key areas of like bigger architectural investments that we've chosen to make.
Is that last one something you talked about externally at all, or have shared anything with it?
I don't think we've talked about it at all externally. I'd be happy to talk about it more, but no, we're not given any presentations about it. It was something within the last 2 years that we've been bringing online. And I think we've had relatively good success with it.
Awesome. Okay, well, if no one else has anything, thanks for choosing to listen
Send
to our
us any
presentation.
questions if you think of them later.
Yeah.